Good morning everyone. In today's video I'm going to show you the last step of making the snowflake tower, and specifically in this video I'm going to make the vertical louvers, or the vertical elements that you might seen in the previous work that I've done in this picture. I made the solid objects, and then we make the surface. If you remember of the last video of the Snowflake Tower series, it's 11 videos, video number 11 specifically, and we made the surface, and then we made the solid, and the solid give us those horizontal elements in the slab later on, and the vertical one, or the surface one, actually give us this skin, with the crown on the head. And those horizontal elements we made by exporting the geometry to Revit as a conceptual mass, and then we slice it rather than the vertical elements, and the division we made it based on the surface itself. But again, we need to get back to the surface, and we create from it this vertical element, as you can see, running on the face of each each part of that elements. I get this what we stopped last time from the Snowflake Tower, step 11. I got a question from one of my dearest subscriber, Ego. Here is asking for doing and completing this, and for everyone is watching, making the vertical elements, you can do that actually in two methods. You can go ahead and make that as an adaptive component and apply that, and made out of just a vertical elements that have to be continuously to each other at the top ends. Or I'm going to just make a sweep here. Probably it's basically easier. Anyway, that's what we got in the last time. And the lower part, it's just making a solid, so I'm just going to cut that out and then go up and make the second part here, and creating a surface out of that. So probably we need to activate the preview and then regenerate the whole thing, and you're going to see the previous part you see is stopping here and get us the solid that we get the horizontal elements in it. And that surface one, we get the crown, and we need that to create the skin here, and that we did in the previous exercise. And also we need to divide each part of that surface and create the vertical louvers in it. Anywho, so get back to this one. So we got this surface, and if you activate this, you get a notice that that's the one surface. So it's a poly surface actually, and you can go ahead and have a topology, and from the topology I can just get the faces out of that, and if I run that, now I get the topology making or changing the poly surface into a topology of faces. So those guys, just the faces that created in here. And again, we don't need faces in dealing with this. So what we're going to do, I'm going to have a faces dot surface to get them back to an individual surfaces instead of faces that we don't need. So it's actually, that's a poly surface, a group of surfaces united and attached to each other. We separate them into faces, get them back to surfaces again. So now if I run, you're gonna get here, instead of those faces, you're gonna get the surfaces, as you can see. So this is a one whole thing, while this guy is just a faces. It's just divided that into pieces. So what I'm going to do, I'm just going to hide that because I technically don't need that anymore. Probably turning off this. So now I have this, see that, and this, and so on and so on. It's been divided into subsurfaces, or into normal actually surfaces, not as a unified, as a poly surface. Now that's been done. That's what we want so far. And if you notice in the design, the original design by the designer, sorry, the designer of this building, you can see that it isn't running on the curved part, but rather than on part of those surfaces. So it's not on that, you know. So I'm gonna get back in here. It isn't running. Let me turn off that. It isn't running in this, you know, those holes, but rather in this face. So you need to understand that when you select this, just that one, you have to ignore 1 and probably 2. There's a little mistake here. There's an extra point that's splitting that face. So 0 and 3, and you know, you have to be patient to know where to add that. In order to do this, you really need to get a get item, list.get item, to separate things that you don't need, because technically in here, you know, that's the list. And if you're gonna get, let's say, 0, as you can see here, I'm just gonna run that again. See, now this is getting us only 1. Of course, you're not gonna see it because this is still alive, so just need to, you know, see this. Now you get only that element or that face by itself out of this list by using the list.getItem, and on that you will go ahead and, you know, use the, you know, the ISO or surface.ISO. So technically you're going to draw lines following the curvature of the surface. So that's my surface. The ISO is usually 0 or 1. I'm going to go 1, so it goes for a vertical ISO. Putting it up, and the parameter is how you want it. So if I say it's 0.5, for example, it will be in the middle, as you can see. And instead I'm gonna go 0 dot 1 dot 0.2, and that's gonna again give us a starting from a 0 point to the end. And if you go back to the points here, you won't see those much closer to the, you know, to the edges. I'm not really quite sure that it's run close to the edge. I think it's yes. I don't know, not really clear for me. So I'm just gonna ignore that in the edge. And also to make it quicker here, I don't know, I just don't want to get into too much of making this, so I'm gonna ignore the first one. So starting from 0, I'm gonna start from 0.2, and instead of ending at the end of that, which is here 1, I'm gonna just skip up 0.2, making this 0.8. So I'm gonna start from here, ending here, instead from the beginning to the end. Run that thing. And in here you're going to see, you know, starting from 0.2, ending by 0.8, and jumping with an interval of 0.2 each. Anyhow, now technically mission accomplished. I created an Isolines that, you know, run all over this surface, and you just need to go ahead and create you know, a shape on that, and then, you know, do the sweep on it. But before, you're gonna need to repeat this on each one of those surfaces, and it's really gonna be a bad idea if you do that one by one. So instead you need, you know, to go ahead and do this on each face of those. Don't repeat. The point I'm trying to tell you is not to repeat this group of nodes like, I don't know, 6 times in order to do on each one of those faces, but rather just know which faces you want, add them to the code block, and this guys will repeat it for all. Anyhow, so that's 0. I'm gonna skip 1 and 2. That's 3. So zooming in here, so let's add 3, and then probably we need to go a little bit to rotate around, and then probably 4. No, I don't know, it's too slow. Now 5 and 6. No, 7, I guess. and then we have to rotate again. So 8, no, of course it's look like 9 and 11. So that's 9, that's 11, and all what we really need now is just to, you know, run that script. So that the beauty of the code block is just actually, you know, allow us to, you know, prevent the repetition and do that in one code. And as you see the failure that I get in here, it's almost a mess up, and the reason is that this dude here is getting a repetitive matrix of, you know, the numbers that we listed in here, but it's just, you know, following the shortest part of it. So which one, I have no idea actually. So let me see, I have to change the lacing to cross product. Let me see this one. I don't think so. I think it's in here. Anyway, that's an error. Okay, so it's just the lacing. Come here and change the lacing to cross product, and it should work now. See? So don't freak out very quick. You get now the result, and now that's the surface.getISO now. Understand that you need to repeat, you know, for each one or each item of what this guy is, you know, for each surface you have to repeat the whole thing, not the overall, to get the shortest path for it. Anyhow, now we get ourselves, you know, our lines. Now we need to organize and work for making the cross section. The cross section in the sweep should actually be on a specific point on that line, on each line actually, and it have the cross section have to be perpendicular at this specific point too. So what we really need now is to create that point on each one of those curves. So just a curve dot point add parameter. So that's my curve again. The parameter is wherever you want. We're just zooming in here, and let's say the parameter, let's say 0.1 maybe, like this. If I get to run this thing, okay, now you will notice that I get a point in here at each one of those lines. Now it's getting a little bit of a mess here because I can't start seeing, so probably I really need to go to the topology, deactivating it, remove that preview, probably the surfaces also, just turn it off, and those parts of the surface that we just selected also turning them off, and we're gonna get better results. And now you see that we have those points, you know, at a 0.1 of the length of the each one of those lines. Now we need to create a plane so we can recreate a shape. So again, plane on each point. That's my plane, and we created the plane because we need to create a rectangle. That's my rectangle. Come on. And we need to specify the width. You can make a slider if you want. Let's say the width 1.5 meter by 4, 0.5, I have no idea. Now we have, by this we're going to create a rectangle on each point, on a reference plane on each point of that. Some of them are, you know, going well because that's the way we want them, and some of those guys are actually, you know, have to be rotated somehow, and that could be enough for some of you. Just go ahead and, you know, just extrude or make this sweep You know, for those it's okay, for those not. So you either separate them manually and add the rotation. You can define an automatic function to create the rotation by creating the perpendicular, or knowing the perpendicular, the tangent, and then the perpendicular line on the tangent for those, for each one of those curves, and then go to that curve, you know, on the ground, draw the tangent, knowing the perpendicular, and then compare those angles to each other. So you will create an automatic function to rotate that plane, rotating that rectangle, in order to get the perfect an automated generated angle for the rotation on the surface. I'm not going to do that. It's going to almost take forever. So what I'm going to do, I'm going to add a manual rotation to do this function, so you can control it the way you know you like, in more detail, and allow you actually to control that manually. So that's what I want so far. Now I will need to start to get the rotation for each, or actually for those who are not really rotated in the way I like. Let's go and go rotate, and in it, then not that one, of course. I think this one. Let's see, it's geometry, origin, axis. I don't know. Yeah, probably this one. So now that's the rotation. Now you cannot select them all. All of them actually now is based on a list here. So you know, you don't need those all. You need to actually to separate them. So indeed you need a get item, and where is it? I think this one. We're just gonna, you know, copy them. So I'm gonna take those rectangles and I'm gonna pick, let's say, the first group of them. Okay, so those are the shapes that we need to rotate, and yep, we need now to get that in here. Some lagging here, sorry guys. That's to be sufficient to do the rotation. Now we need to know where is the baseline, and the same thing we've done in here have to be done for the baseline, except that we need to select the thing here, the planes, because I need actually to rotate the plane itself. And again, I just selected wherever this here, those group of rectangle with, you know, those group of planes. Okay, so the first four with the first four, just gonna hide that. Now degree, it's depend on what angle you want. I just pre-done that. I think 15 is enough. Let me run that, and if I zoom in a bit, you see 15 is, I think, as good as I get in here. Of course the remaining, the original one, those guys have to be, you know, turned off in order, you know, to not seeing the two cases or two shapes in the same place. So I would rather here go and continue. So that's my geometry, or the rectangle, perfectly rotated. So probably we need to go ahead and make this solid by sweep. So this one. So what it's need, actually it's need the profiles. That's the profile, rotated and ready. Now we need the path, and again it's a list dot get item, again lagging for no reason. And here we go. So the same thing, because the path, there are list of the paths, so we need to get to see which path we want. Of course not, those are the paths, don't forget, they're just the curves. So no, that's the point, sorry. Those are the ISO lines, those are my paths. I'm going to take the first set from them and give them here. So that's all, should do the trick for a first object. Like this, maybe, I don't know. Okay, so let's run. And as you can see, now we get our vertical, louvers on each, it's not actually on each one of them, but rather on the first curve. I made a 4, you can create 5, you can create any number you like, Now, this guy here, you can go ahead and select them all and make them group, and to ease the pain in the copy and paste, I'm trying to make a copy, of course. Yeah. Now I've done that for the thing in 0. So what do we need to do in here? We need to have a look at this guy. So it should be on curve number 3, I think. So, isn't it? No, it should be 1. Because that's the list coming from here. We don't need to ignore number 1 in it. So 1 here and 1 here to get the shape. The rotation, I think, in this one was around 45 again, to get that rotation of those objects. And then list.item for the solid, we have to get the paths of the second line, which is this one. Technically it's going to be number 3. Just number 3 is coming from here. That's 0, that's 2, that's 1, and that's 2 a little bit. That's a mistake in here. So 3, okay, 3, 5, and go on. Now let's test this guy. Come on. It should give you the second rows, or those 4, or those, I have no idea, probably those. And get the vertical louvers to be built, and of course have to be rotating those rectangles and the plane that actually contain them. Wow, that's crazy wrong. Let's see what happened in here. Wow, what is this? Alright, that's scary. Let's go back and see what we've done. So what we've done here, let's say why is that. So the profiles, that's the geometry, okay. And the path, something is wrong. Really wrong. Okay. So what's happening in here, we have the rotation done correctly. We have no problems. Good. So what's the problem? So let's see again. So if this, really nice, it's happened. So look, we have the list.getItem.index, and that rotation happened correctly for that. So the problem in those 3. Good to see. So which one? If I select this, okay, that's why. So those number 3, those are the paths, while those here are the shapes. That makes very much sense. So why I select the wrong lines? That's what I've done. Okay, good. So let's have a look. What are those? Get back to the, this one. It's not 3, probably it's 11, so we need to activate this. No, 11, where are you? No 11 in here. It could be the 1 2 3 0 1 2 3 4 5. Is it the last one? No, the one before the last one. No, also no. And it should be list 2. Oh god, technically list 1. Okay, so 1. Okay, let's try 1. Yeah, because the list should follow the same number as here. Okay, it's my mistake by assuming I have to follow this. I should follow this one because it's filtered out of here, and the sequence of number is going to 0 1 2 3 again, not 0 3 5. Okay, my bad, sorry guys. Run that again. Good, it happens. So we learn from this mistake. Let's see if it's been fixed in here. I think it's done and it's perfectly fit. You can see it's running perfectly. Anyway, so I will leave you guys to do the rest. Just a tip that I've done 1 and 3, sorry, 0 and 1. Number 2 will need to be, I think, minus 50. Number 3 should be 0. Number 4 should be 90. Number 5 should be 90 or minus 90, not really quite sure, to get the overall vertical louvers. Here I highly advise you to send those or to create those on the conceptual mass and then send them to Revit. And of course, don't forget, after you finish, you need to get back to the rectangle, and then you have to make them turn off the preview so you don't have too much. Even I think in here you probably need to turn on those off so you don't get too much of the shapes in here in the middle of the way. You get to do the same thing in here and here, so you don't see those been repeated all the time. You probably need to do the same thing with the planes, and you're gonna get a very nice vertical louvers that follow the surface, and it's in the same time it's been created by a sweep for a rectangle to overall length of those curve. Anyway guys, I wish that you find this video useful. Thank you very much and have a good day. Bye bye.